Hello again, for those that are returning for the second episode of Skynet, a Lisp Machine Development. Today I've got a bit of a plan. I'm planning on doing a documentation update over here on the Lisp help side to make sure we have all of the actual functions and special forms available or documented that are available. I'm going to be doing a quick Lisp overview for those that don't know any Lisp at all. And I was going to fix a bug in PX2, or at least maybe help with debugging certain styles of bugs that happen in PX2, which is the underlying framework that I use in Skynet that I wrote. So without further ado, we'll get to documentation update. So luckily enough, we aren't going to have to hunt for where the documentation is. If you see on the left here, this is the terminal application. Where the options or where the help is printed when you first boot up. So that's pretty easy. So we found that. So this is what we're actually going to change. Now what we're going to do is we're going to find all of the special forms that are used. This here is the function eval or be eval and sigil, which is the underlying Lisp implementation. And as you can see, there's a few of them that I've forgotten. So we're going to add them in. Set queue setup. Okay, so we have quote and queue quote are a bit different, but we should add them anyways. Quote, well, queue quote on a different line. Lambda is there, set queue is there, values is there, multiple value bind is there, symbol function. That's a interesting one. So I guess maybe I do have functions with setf if that actually works with symbol function. We have def macro, we have cond, EQ, and progin. There should be another one in here. Unquote and unquote splice, but maybe they're somewhere else. We won't worry about that. Cond and Q quote. Sorry, I'm just thinking if you would ever actually use Q quote. Well, we'll leave it in there anyways. So those are our list of special forms, and if you don't know much about Lisp, a special form has to do with how things are evaluated. Basically, a function, all the arguments you pass to the function are always evaluated from left to right once, and then passed to the function. So that's pretty standard when it comes to most programming languages, except for Haskell and other lazy languages. But what a special form is it changes how things are evaluated. The most basic example is set queue. It doesn't evaluate its first argument. The second argument is evaluated, so that's a special evaluation rule, and thus set queue is a special form. That's what the Q stands for. Quote. So, okay, enough of that. We'll do this. Continue with our built-ins. We have, we'll put set up here. Car cooter, cons, apply. Lambda apply, env and fenv. Oops. And the FM, and the standard plus, minus, multiply, and divide. So yeah, I do have symbol function, but we have to figure out if that actually works, and that might get fixed in a later thing, because there's no defun, because setf symbol function with a lambda after it will define a function in the function namespace. So I probably left defun as an exercise for the user as they build their own Lisp from these primitives. Like I said in the last episode, one thing that is glaringly missing from the list of McCarthy Lisp operators is labels, which allows you to define local functions within a lambda, because they didn't have, they didn't have set. He didn't have set in the original operations, so there was no way of defining functions except with labels. That's how it worked. Sorry, hopefully not boring you with Lisp history and knowledge, but that's part of what this show is about. It's not just about the design and development of a Lisp machine, but it's also to show off why Lisp is cool, because us Lisp people like to do that because we think that it is the most powerful of languages. So, because after the experience that I've gathered over the years, it is in an interesting way. It's like having a superpower, sort of. So we have a little extra new line up here. Oops. And what else do we have to do? It looks like we've bound or documented. Do we have RM and RMF? There we go. Save and load. Okay, so we've documented everything in the Lisp. And booyah, looks like my refresh worked. Now, one thing, if you've actually tried out Skynet, there is a glaring bug right now where if you hit E in this buffer, you go into a CPU spike. So make sure you clear your buffer before you hit E to evaluate your stuff until I fix that, which might even be today if I feel like it. Another pro tip is you actually have to click in the title bar to focus the window before you can actually type in it. I sent a link to Skynet to a friend and he was not able to figure out how to, well, I don't know, he didn't really try that hard to figure out how to focus the window. So one mistake is to click on the window. That doesn't actually focus it. You can be reminded of that by the black tile and click on the top, and then you can type, and it's your currently focused window. Okay, that's the end of part 1, which was the documentation update. Nothing too exciting, but at least you got to look at a bit of code for a while. We'll get more into that later. So what we've got now in my plan is a Lisp overview. So the other complaint of my friend about using Skynet was that he didn't know Lisp. So that's a problem when you're using a Lisp machine. So we're going to go over a little bit of Lisp, because why not? Okay, so the first thing we have, we're going to go in order actually, for what the things are. So we're going to start with quote. So if you were watching last time, you might remember I defined X, and one of my favorite things to do in Skynet is to see what the current value of X is, because that's sort of a making sure the core was loaded and all sorts of stuff like that. So what I just did there is a normal evaluation. Lisp took that symbol, evaluated it, and then gave me its value. So that's pretty normal programming stuff. So now what we're going to do is we're going to quote X, which was the first thing in the documentation there. And as you might see, quote X returns X. So basically quoting turns off evaluation, returning one of the two basic data types in my sigil Lisp, a symbol. So X and anything else in Lisp that isn't a number is a symbol. So that's just something you need to know. There's two types. Let's move on. So we have quote X. So the next thing in the list was set, which was not one of McCarthy's originals, but something that's kind of essential to really get anything done. So set sets values, as one might expect, but one thing it does, if you remember from the discussion on special forms, set is actually a function and not a special form. That means that both of its arguments are evaluated, which sometimes could be very handy. Say if you're using a function that's returning a symbol that happens to be a variable name. That might be cool to do someday. So to use set, you can set a value. Remember, it's going to evaluate its first argument, and the first argument has to be a symbol, because if you can't just set numbers, that would just be wrong. So we're going to change the value of X. This is how you do that with set. So now we've evaluated that. Now we're going to check the value. Check the value of X. And it set the value of X. There you go, just like an equals sign. But you have to remember to quote the first symbol, because let's see what happens if you don't. And as you can see, it's rarely used. You almost always use set Q, which I'll get to in a second. But I think you might have figured out what that's for. So if we try and set unquoted, oh, look at that. You get a nice little error message actually telling you what happened. So the solution to that problem is set Q, which is a special form, abbreviation for set quote, and there we go. You don't have to quote the symbol with set Q. So we jumped a bit ahead there, but that's just something important. Now we have cons. So Lisp, L-I-S-P, the name actually stands for list processing. List processing is kind of important, at least back in the 50s when Lisp was invented or discovered. So the basic data structure, in fact, everything in this Lisp sigil that isn't is a list. So actually, sorry, I lied. There's 3 data types. There's lists, symbols, and numbers. So everything in Lisp is a list, including the code you're typing, or I'm typing. So an example of a list, oh, I forgot a shortcut. So if you recall back a little bit, we had quote X. So we quote with that. There's a shortcut, single quote X does the same thing. That's a macro character that expands to quote X. So I'm going to use that right now to keep from evaluating the list I'm going to show you. So, a list is any number of numbers or symbols or other lists in between an open and closed parenthesis. So that's a list, and that's basically everything inside a Lisp machine is a list of numbers, symbols, or other lists. So that's a list. Now we were on to explaining what cons is. Cons is short for construct, and it builds new lists. So if we look, it builds a new list. Cool. So that's basically what how you build things or allocate memory in Lisp. So one thing, actually this is interesting, but I won't get into it. That should be a dotted list, but it's not. And I'm actually wondering if I made Sigil have the ability to create dotted lists. But we'll figure that out later, because dotted lists are pretty important. So now we're on to car. Car and cdr. Those are ancient names, the original names. They're actually short for contents of address register and contents of destination register, I think, which were instructions on the IBM mainframe that they used originally to write the original Lisp interpreter on. So what car does is it returns the first element of a list. There we go. So as you can see, 1 was returned from the first element of the list 1, 2, 3. Now we have cdr, which returns everything after the first element of the list. So 2 and 3 come out of there. So that's basic primitive operations. Now just to combine two of the things that we've already done, car cons quote A and quote B will return A, and cdr will return a list with B in it. So there we go. So those are the basic, except for set, Lisp primitives that were found or discovered or invented by John McCarthy back in the 50s in a very fundamental paper in computer science, which I'd really have to remember the name of. Something about the evaluation of symbolic expressions. Of course, I do have the internet here. Recursive functions of symbolic expressions and their something or other. So you might want to check that paper out because it's pretty cool. We'll go over some of the other Lispisms in a different episode to keep this one from going on forever. We'll get back to programming. But let's just say if you feel like following along and doing some homework, read the original McCarthy paper, because it's pretty awesome. Okay, so that ends segment 2 of this episode. And now we're going to move on to segment 3, which is working on the low-level framework that I wrote for some reason to make my own framework, I guess. I was taking a course last summer in web development from Hack Reactor through work, and we learned Backbone, and I thought it was pretty cool once I figured it out, except it sucked. You couldn't do the most basic of ideas, like putting a collection inside a collection, or having views that acted like models in a certain way. So I wrote my own and redesigned and did a better design. Or at least I think it's a better general purpose design. General design, let's say. If you want to know more about it, go to npmjs.com and search for PX2, and then you'll find it. And it's fully documented here. It's basically Backbone, but better. So there's a couple examples at the bottom. There's a couple examples on models. You do have to know how to use Backbone, and it's open source, so you can check it out on GitHub at my GitHub page. It's got a problem that I'm trying to fix, or figure out how to fix. There's this central tenant idea of PX2 and Backbone of signals or triggers. There we go. So we've got this section here. Oops. We have this section here, which is basically the triggering code, or the triggering API, which is essentially it's kind of like exceptions. You throw an exception, or you trigger something, and then somewhere higher up the chain you have to catch it with an on message, or an on call. So an on call sets up a set of handlers to deal with triggers from objects that are contained within itself. We'll get to that later in a PX2 overview. But what this does sometimes, and this is the bug that I'm going to at least try and track a little bit of down, is you get into something called a trigger loop. And if we look over back at Skynet, every once in a while we'll see uncaught range error, maximum call stack size exceeded. So basically we get a stack overflow. This is due to a trigger loop, and I still don't know how to find them very good. So this is basically me adding a bit of code to help me try and track this bastard bug down, or this bastard class of bugs down. So yeah, let's get started. Basically the idea here is that we have an uncaught range error around this call here. So I'm just going to catch that exception and see if we can print out some debugging stuff. So if you notice here, there's actually PX3. So this is actually in PX3, but any major bug fixes are going to go back into PX2. I'm just thinking that PX3 is going to have some new features and might not be completely backwards compatible with PX2, so gets a major version bump. So we're looking for trigger. Oops, not Tigger. Trigger. Let's look for prototype.trigger. Okay. So we have prototype.trigger. So one thing you might notice about this JavaScript code is it's got some pretty ugly variable names every once in a while, especially in loops. That's because it was actually compiled, or transpiled as people say these days, from paren script into JavaScript. So for compiled code, it's actually pretty clean. But I've kind of not given up on paren script. I just kind of feel like reducing my tool chain weight. So now I'm just editing the compiled JavaScript code directly. Okay, so this was the line that we found. I'm gonna just put an exception handler. What is it? Catch E. This is still an error. This is the format I use for my console messages. We should probably put the right project in. Console error trigger. So basically what module it is, what function you're in. And we know what this is. Trigger loop detected. And then we're just going to print out message value trigger loop detected message value target. So it should at least give us a little bit of information, maybe, we can hope, to try and track down where these trigger loops happen. Basically, I've been hacking little solutions to it here and there. They aren't very interesting. You just catch the trigger that you're generating inside a model or view. But I don't like it. And we have a... Did I forget? Usually I forget a comma somewhere. Oops. There we go. Oh, come on. Oh, what? Oh, and Chrome has this really interesting feature. Once you have a syntax error, hopefully we get some Chrome developers watching this. When you get a syntax error and you go to it, it won't actually reload. It gets stuck in a loop here. It's really frustrating. Okay. Oops. Okay. So we had trigger loops. We just put in some debugging information for trigger loops. Uncaught exception. Okay, like any programming task, when done for the first time, that didn't work. Sorry, I'm just thinking to try and figure out what might have happened there. Let's try that again, because okay, so I clicked here. No, I didn't click there, but I clicked here. That's interesting. Zero 156. Uncaught exception. Okay, so this is getting to my my edge of JavaScript knowledge. What could this be? What could this be? Okay, well that didn't effing work, but I like the idea. So we're just gonna leave that there. And think about this some other time. So if you've made it this far, thanks for watching. I'm not quite finished yet. That were the 3 segments. Unfortunately, there was a fail on the last one, but the first 2 hopefully got you a bit more interested in Lisp and basically gave you the ideas, a bit of ideas on exploring further. I keep forgetting what all the McCarthy Lispisms are, but oops, that was weird. Oh. Sorry about that. Come on. There are others that I keep forgetting to talk about. Lambda, apply, eval. Whatever. We'll just restart here. And we have that there. That's what the problem was. And a breakpoint left over. That's why I normally debug with console.log, because I keep forgetting that I've set breakpoints and put debugger statements everywhere. And I have to clean them up. Oh yeah. So for those of you that have actually made it this far, one thing I neglected to do, because I don't think it was actually up yet at the time, was show you where you can find Skynet to play with. It is online. My site is called busfactor1.ca. There's a whole bunch of stuff up there, but you probably won't be able to find it. And if you want to try Skynet, just go to bin Skynet. What we've got here is a few interesting things. We've got this video, or the last video that you can watch, which was the demo, original demo, but you probably saw it if you're watching this. And we've got an interesting interview with John McCarthy, the guy I keep talking about, the guy that discovered Lisp, or invented it, or whatever your philosophical view on mathematical discoveries is. Just the guy. So we've got some stuff. If you ever want to send me an email, that's my email address. And then we've got a big engage at the top. Well, that's just something I say whenever I want to click on something to do something. I click engage. So just click engage, and you'll find the current version of Skynet. So just go there. So if you recall, we did some changes here. So we're going to publish a new version. So we're going to publish a new version of Skynet. First, we're going to commit our changes. Doc update. Attempt at tracking down trigger loops. Okay. And we're going to hit version. Now this does something, and then we're going to do a sync. So now we're going to check our live version of what's currently up here, and it's the newest version. Good, those scripts work. That was the first time I tried them. Now there's a pro tip here about bus factor 1. If you have a URL and it had a previous version that you want to go to, just prepend old to it. So basically this is the version that we had before. This works pretty much anywhere on the site, including the home page. So you can traverse down olds until the cows come home, or you run out of olds and find previous versions of the pages, which may or may not work, and links to stuff that might work and things like that. Anyways, enough about my site. busfactor1.ca/bin/Skynet. Give it a try. You'll find a downloadable copy of this video there. And yeah, that's it for today. Thanks for tuning in. I hope you enjoyed the music better this time. And signing out. This is Bert and Samuel Grad. Engage.